I think we are good to go now. Okay, so we are talking about financial applications. Talking about financial applications. So let's see how, like I said, overall it looked like some of you guys remembered how to do everything, but a lot of you guys forgotten some important factors. So let's take a look at there we go. This here, this is straight from your reference booklet. Compound interest. That formula is going to be given to you when you guys take your exam. FV, which stands for the future value, equals PV, your present value, times 1 plus R, your that's your rate of interest, divided by 100 times K, K being your number of compounding periods per year, raised to the K times N, and represents your number of years. Anytime you're dealing with a financial application problem, this is the formula that you can use, this is the formula that you can rely on, and this is the formula that you are given, okay? And in this particular example of Bob and yes, that's their names, you wanted to use that, okay? Again, in your reference booklet, plug everything in, solve for what you don't know. Simple interest was another concept that we talked about with financial applications. A lot of times, simple interest, the problem will indicate when it's time to use simple interest. It usually says the word simple in the problem. Compound interest, they usually say number of compounded quarterly or compounded annually. That's another thing that kind of lets you know, okay, I'm dealing with compound interest versus simple interest. Okay, so being able to identify and recognize which words go with which problems or which formulas go with which problems, those are some of your trigger words there. Okay, so for our particular example here with Bob, he invests 600 euros in a bank that offers a rate of 2.75% compounded annually. The interest is added on at the end of each year. Okay. So again, compounded means we need to use compound interest, calculate how much money Bob has in the bank after 4 years. Well, if I'm trying to figure out how much he has after 4 years, what part of the compound interest formula am I looking for?
The future value.
The future value. So that means it's going to be FV equals, now I have to plug everything in. My present value is
600.
600 plus or times, sorry.
1 plus 0.0275.
Did you just say 2.75 or point?
I said 0.0275. I made it into a decimal, but.
Okay, now in the formula, since it is being divided by 100, you want to leave it without actually converting it over, okay? So the formula is being divided by 100, you just want to plug in the rate the way that it is, okay? So this is our R. What's our K?
1.
1, because it says it's compounded annually, raised to the K times N. What's going to be N?
4.
4. Okay, and then from there, we just type that into our calculator to get our answer. What did we get?
669.
Very good. That significant figures. You could have also said what?
668.77.
Yes, because since we are talking about money, you know, you could always use 2 decimal places unless the problem specifies otherwise. And did you guys remember to include your units? Some of you all did. If I look back at it. Okay. So now it says calculate the number of years it will take for the investment to double. Well, how much did they initially invest?
600.
So double would be what?
1,200.
1,200. Yes, and since I'm looking for my number of years, what variable am I looking for in the compound interest formula?
The
And
rate, the R.
I'm looking for the R. So now I'm gonna plug everything in. I'm gonna plug in 1,200 because it's set to double. So I double my initial investment. 1 plus, well, my rate is still the same, hasn't changed. My number of compounding periods hasn't changed either, has it? Now in this particular problem, I have to figure out n. N is in my exponent. What do I use to determine this? Like what process do I have to go through?
We can graph it and then find the intersection of y equals 1200 and y equals 600. 1 plus 2.75 over 100 times 1 to the power of 1, and then instead of putting n, we put an x.
There we go. So we want to graph it, okay? We want to graph both equations, graph 1,200 into y1, then we want to graph the other side into y2, and what we're doing is we're looking for that intersection. We never want to put y1, y2 on our actual paper that's calculator notation, okay? You never want to put calculator notation on your actual IB exam. Now, what I just did right here, I drew a rough sketch of what the graph should look like, and then I indicated the intersection point. That's what we're looking for. We're looking for the corresponding x value of where the curve is going to actually equal 1,200. Did we get an answer?
$25.6.
25.6. Okay, so
What did you guys use in your windows? Because I tried so many different numbers and I couldn't like get an intersection.
I just used 30 and then negative 30 for both y and x.
Okay.
okay. So n equals 25.6. Okay, very good.
I thought n couldn't be a decimal.
When you're talking about like time, when you're talking about time, like numbers of years, it can be a decimal. If you're talking about like people or animals or insects, then you want to make sure that you're at your whole number. But when it comes to time, like years and things like that, unless it says complete years, then you want to use the decimal. However, if you did put 26, you would not have been penalized. I'm looking at the mark scheme and it says that 26 would have also been acceptable. But as a rule of thumb, when it comes to time, 3 significant figures, unless it states otherwise, okay? And after we go over C, I'm gonna show you, I'm gonna do part B in the calculator. I also wanna show you something else in the calculator, just to make sure that, you can see this actual graph. Lastly, for B or C, it says Ann invests 600 euros in a different bank account that offers an interest compounded annually. Her investment doubles after 20 years. Again, we're still dealing with compound interest. This time we know that it doubles after 20 years, so 20 represents what?
N.
Yeah.
N, and we're looking for our rate, so we're looking for our R. So we would set it up as, what's FV?
1,200.
Because it said that it doubled. Our present value is 600. 1 plus R over 100 times 1. 1 times 20. Okay? And then what this is pretty much, you could do it the same way. You could graph it, or you could solve it a regular equation by dividing 600. That gives you 2 equals 1 plus R over 100 to the 20th power. To solve for R, I would need to take the 20th root of 2. I would get a decimal. Whatever decimal that is, don't tell me, you just know it's some decimal. You would subtract 1 and then multiply your answer by 100 to get your rate. Did we get an answer?
3.53.
Very good. Questions on using the formula to get our answers? So real quick, we're gonna take a look at how to use the calculator. Just do a couple of things. The first thing, let's just make sure that when it comes to like part B, when we had to graph that equation, let's see, it was 1 plus, remember alpha y gives you the fraction 2.75 over 100 times 1, which is just 100, raised to the 1 times x power. Remember, we want to adjust our window so that way we can see. Since y equals 1200, you at least want to change your y max to be 1200 so you can at least see that horizontal line. We're going to cross our fingers that my calculator doesn't crash before I can get this answer. You want to open up your x max, because remember your x represents your years. So, you know, you can open that up to 50, 100, but you want to open it up just so that way you can see everything. There's your 1200 line. Here comes the curve very slowly. And we want to get that intersection point right there. How do I get that intersection point? What was the process in the calculator I do?
You move the little cross to near where the intersection is. Then you put
After I click what though?
the arrows. There's like 4 arrows. You can just drag it there. Then click second calc and then intersect.
Okay.
And then,
So that's what I was looking for. The second trace, okay? Second trace takes
oh yeah.
calculate, and I want to go down to option 5, and then yes, move my cursor close to that intersection point, and then click enter how many times?
3.
3.
And then that's how we got the 25.6 number. Okay, good, good. Something else that I want to just make sure everybody knows how to do. Remember, for part C, we had to take the 20th root. Where do I access the 20th root from? Who remembers?
Math.
You go to math, and you go down to
And then 5.
option 5. Now, if you have an older calculator, it won't allow you to do it this way. So you actually would have to do 20, then math, then 5. So then that way you're able to do, you know, the 20th root of 2. That's how we get this decimal. Then, you know, we had to subtract 1 and then multiply that by 100. And that's how we were able to get 3.53. Okay. Also with financial applications, there was a calculator way to do all of these questions, okay? That was located in the app section, and then in finance, and then TVM solver. Do you guys remember this from last year?
Yes.
Okay. And so this here, this is what, you know, you could have used this as well. If you do choose to use this, this is like one of the only times that calculator notation is okay to use. You just would have to literally write down everything you see in the screen and then fill in your numbers as your, you know, as need be. So like for A, when it asks you to find the future value, okay, you would plug everything else in. Like we knew that N represented our compounding periods per year. Well, our compounding periods was, you know, annually, but we had to do it every 4 years. So you take the number of compounding periods and you multiply it by your number of years, okay? Does everybody see that 1 times 4 on the screen?
Yes.
I want to make sure. All right, so you could do that, or you just type in 4. You would type in your interest rate, which was 2.75, exactly how it's given to you. Your present value is always negative. Your present value is always negative, okay? Payments was always 0. Since I'm looking for future value, I wouldn't put anything there. Remember, P/Y stood for payments per year, and this C/Y stood for compounding periods per year. So if it was like quarterly or monthly, you know, you would change your C/Y, and it will automatically change your P/Y. Payments were at the end of the year, and so we would go down to future value. Oops, I had to take it back to this. Since that's what I'm looking for, we would press alpha equals, and oh, haha. I didn't actually type in any information. I wrote it down, but I never typed it all in. Sorry. I was like, why is it not working?
Can you explain to us why the PV is negative 600?
Because it's gonna, that's what allows your future value to be a positive number. If you put in the present value as a negative number, then you're gonna end up getting a future value that's negative. Now, you can do that, it'll still give you the right answer, it just end up being negative, but you just have to know that future value is actually positive. So it's something with the programming, with the application. So I go alpha, enter, and that was the number that we got for future value. Okay. I could have done the same thing with C, with the and situation. Remember, Ann was, she wanted to find her interest rate after 20 years, and her amount doubled. Well, it was still being compounded annually, 20 years. I'm looking for my interest rate, so that's where I'm gonna go back and solve for. Her present value was still negative 600, and her future value was 1,200. So if I went back up to my interest rate and did alpha enter, there is your interest rate. So the application, you know, it's if you remember how to type everything in, you could also use that to solve. You just want to make sure that the work that's associated with using the application, you just literally would write down everything that's on your screen, and then that would suffice for work. All right, so we're gonna look at this one. It talks about simple interest. And how do I know that it talks about simple interest? Well, let's look at the problem. It says Hassan invests 10,000 CHF at the end of 1971. The interest rate is 5% per annum. How much interest in total would Hassan have earned at the end of the year 1999 if he had removed the interest from his account at the end of each year, and if he had not removed the interest at the end from his account at the end of each year? What word is missing in this problem? So that I know it's not the other formula that involves FV.
Compound.
Compound. Okay. Yeah, I know this is not a compound interest problem because it doesn't say anything about him investing his money compounded annually, compounded quarterly, you know, basically getting interest at certain points in times in the year. So that indicates, even though it doesn't say simple interest, the only other way that he's going to be able to get interest is through a simple interest process. So this is an example of simple interest. Now your simple interest formula, just to refresh your memory, is I equals PRT, where I represents your interest, P represents your principal, R is your rate as a decimal, and T is your time in years. So for Hassan, if we're trying to figure out how much interest he has at the end of 1999, if he had removed interest at the end of each year, then we are going to use the simple interest formula. Let me annotate. Okay. So that's going to be I equals P, which is the 10,000. That's how much he initially invests. R, his rate is 5%, so I put that in as a decimal. And then the number of years. If he invests that much money at the end of 1971, and he's trying to figure out his interest at the end of 1999, how many years is that?
29 years.
How many?
29.
No, not 29.
28.
It'd be 28. It'd be 28. Because it's at the end of 1971. So then I would type that into my calculator and I'll figure out how much interest he has if he had removed his interest from his account at the end of each year. Can you guys type that in and tell me how much he's gonna have?
$14,000.
14,000. And of course, we want to include our units. But how much is he going to have if he had not removed his interest from his account at the end of each year? What would I use here to determine this? So basically, we know that he's not taking out any money, no interest, nothing. And so his money is just continuing to accumulate over the years. So over the 28 years, his money is accumulating. What concept basically allows us to accumulate a certain amount of money after a certain number of years?
Compound interest.
But this isn't a compound interest problem. Yes, that is true. That is true that allows us to, but what other concept?
Sum.
Sum of what? Because sum does basically tell us like the total, yes.
The sum of what he gets every year, like the money he gets every year.
What concepts
From what concepts are
associated with sum?
series?
That's another name for sum, but like we just talked about it last week. What did we do last week?
Arithmetic sequences and series.
And
Geometric sequences and series.
so is this particular problem arithmetic or geometric?
It would be geometric.
And we know this because it says that he's increasing at a particular percentage, right?
Yes.
So that percentage would basically tell us how much is increasing. So we're actually here, part B, we're not going to use the simple interest formula because he's not removing any interest from his account. He's basically going to say, okay, 28 years from now, I'm going to figure out how much money I actually have acquired in interest, okay? Simple interest formula basically tells us how much interest he has after 28 years. That's if he continues to remove his interest at the end of each year. So in part A, that's how much money he's actually obtained in interest over the last 28 years. If he continued to remove it, and let's say he just put it into a jar and never touched it. But in part B, he's not taking out the money at all at any point. But after 28 years, he's gonna look and try to figure out, okay, exactly how much money has he saved? So for part B, yes, I am recording this. So for part B, we are going to be using geometric sequence, not series, but sequence, because we want to figure out, okay, exactly in that 28th year, how much money does he have? How much money does he have? So geometric sequence. What's the formula for a geometric sequence?
A1 times R to the n minus 1 power.
Okay, so A1 or U sub 1 represents the first year, the first amount. How much did he put in that first year?
10,000.
10,000. What's the R?
1.05.
Yes, it is 1.05. It's not 0.05 because we need to take into account that he's basically taking the previous year's amount and continuing to get interest on them. So in those particular cases, it's 1 plus your rate. So that's why it's 1.05. And then we're going to do n minus 1 or actually we want to be careful here because we don't want to do 28 minus 1. We want to do 28 because if we take away that 1 year, we're not going to take into consideration that he started with 10,000 CHF.
Yeah, so 10,000 would be more like use of 0, right?
Exactly. So let me actually change that. If I change this here, then this would be here. Because that's the initial, not necessarily his first year's amount, but his initial amount. So type this in and get that number so we can figure out how much he has at the end of 28 years. And then to find my interest, what am I going to need to do to that number?
Subtract 10,000.
Because 10,000 is how much he initially put in. But if we're only looking for the amount he's earned in interest, we need to subtract that initial amount that he put in. So now what's our final answer?
$29,201.29.
Or if I wanted to round to the 3 significant figures, it would be what?
$29.
29,200.
200.